Okay, today on the SpongeBob challenge, we'll be looking at finding domain and range from observing a graph. And let me give a quick description of what in the world domain and range is. Domain basically tracks all the input that can be used in an equation. Sometimes not all numbers can be put into an equation, depending on what kind of equation it is. And range tracks all the numbers that are answers. Okay, and you can't. There are many situations where some answers you can't get, and domain and range tracks both of those. Okay, so because domain tracks the numbers that you input, all possible input, domain is always regarded basically as an X. Look at the X's, and range, because it tracks all the answers, it tracks basically Y values. So we're going to use left and right for domain, and we'll use up and down to look at range. So how far a graph goes to the left and right is basically how far it goes along the x-axis, left and right. That will tell us the numbers that you can put into the function, hence the domain. Then we'll look at how far the graph will go down and then up, and that will tell us the answers that we can achieve from that graph, essentially the range. So again, that little combination of looking left, right, and then up and down is what we're going to use here. Okay. So let's take a look. Okay, we have a graph here. I'm going to go to the vertex right here, and I want to look at how far left and right we can go here, and then how far up and down. Cross shape here. And what I see as far as left and right is concerned, this graph will continue going left or right on both sides of zero. So graphically, we're saying that from zero, it goes everywhere left, everywhere right. So we'll say the domain is negative infinity to positive infinity, which suggests that all real numbers can be placed into the equation that made this line. Okay, we'll take anything as an input. Now, range, look at the answers. How far up and how far down? Now, it doesn't go any further down from zero, but it does continue to go up. Okay. So I can see upwards, we're starting from zero and we continue to go up. So I would say the range is from zero to positive infinity. These are the answers that you can get with the function that created this graph right here. Domain and range. Let's look at it. It's another graph, and we're going to look at the how far left and right it goes from zero. So when I look at that, left and right, I can see that it goes in both directions forever. About zero. So graphically, this is how it looks, the domain, along the x-axis. Interval notation, I can say that's negative infinity to positive infinity, goes right through zero. Zero, so there's no gaps. Now, oh, sorry, no, I was wrong. This does not continue to the left. This only goes as far as zero, my fault. So let's back that up. Okay, so this is the actual graph of the domain. It only goes to the right, starting at zero. So let's change this right here from negative infinity to zero. And do a little bracket here. It actually starts at zero. Okay. And that's it. Now the range. The range looks at how far down and how far up the graph goes. Well, this graph doesn't go any further down at zero, it only goes up. So the range has this look at zero. So the range continues to go up from zero, which means we can say the answers start at zero and continue to positive infinity. And there's your domain and your range. Okay, number 3. Okay. First, for the domain, let's look to the left and to the right along zero, which is the vertex here. And at zero, we can see that this graph continues to the left and continues to the right. Therefore, the domain for this is negative infinity to positive infinity. And again, we can also say all real numbers. Now the range, you look at how far down and how far up it goes. Okay, I can see that it doesn't go any further down than the vertex 0. It just continues upward 0. So the range for this right here would be including 0 to positive infinity. Okay, number 4. The vertex is right here at 3, 2. So we're going to look at how far to the left this goes at 3, 2, and how far this goes right. And that will tell us our domain. So, looking at this, this graph doesn't continue any further to the left. Any further to the right. This goes basically from this point to the left. So the domain would be right at 3, and we continue on to the left from the vertex right here. So I would say the domain is negative infinity to the number 3 included on the right. Now let's look at the range. The range is basically how far down and how far up this graph goes. And those are basically detailing the solutions or answers that you get from the graph or original equation. So let's look at how far down and then far up. This graph seems to be going further downward as you go this way, and it seems to be going further up as you go this way. So I would say the range from the number 2 continues to go down and up. Okay, that's a description of negative infinity downward to positive infinity upward, which means that this graph has all real numbers as a range. So this graph or equation can produce any answer, but it's limited in what you can use as an input. You can only input numbers up to 3. You can input 3, 2, 1, 0, -1, -2, -3 as an input in the original equation, but anything past 3 will give you a failure. Okay, number 5. Number 5, we're here at 2, -3 as a kind of starting point. And I want to see how far we can go to the left and to the right. Okay. I see this graph doesn't go any further to the left, but it does go further to the right. So starting from 2. So from 2 to the right, that's the domain. So I would describe that as bracket 2 positive infinity. So that's my domain. Am I off the screen? Yeah, I think I am. 2 to positive infinity. Right. Range. Range, we see how far down it goes from this point and how far up it goes. Okay, I can tell this graph is not going anywhere, going downward, but it's going steadily upward. Upward from -3. So graphically, we're at -3. We're going upward. So I would describe that as bracket -3 to positive infinity. And that's our range. So once again, the equation that they made this graph, you can only put numbers 2 and above into the original equation. And the answers that you can achieve from this are answers that start at -3 and above. Okay, let's take a look at this graph. Let's see here. I'm going to have to change this graph a little bit. And we'll see. Yeah, let me change number 6 a little bit. Okay, number 6. The vertex here is -4, 2. Okay, first I want to see how far to the left and to the right does this graph travel in order to find the domain. And that's across -4. And I can see from -4, it does continue to go to the left and to the right forever. That means it's all real numbers as a domain. So I'll write this down as negative parentheses, negative infinity, positive infinity. Okay. So all real numbers. Now, range, I want to see how far down, then how far up does this graph go at the point 2. Okay. Am I off screen yet? I'm getting there. Let's see. Let's put the range over here where you can see it. Let's put it over here. So the range, according to this, it starts as high as 2, but it goes downward. Okay. So I would describe the range as going to negative infinity, downward, and then only as high as 2, in bracket, will stop at 2. So the numbers that can be put into this particular equation that made this is all real numbers. Put anything, negative, 0, positive. But when it comes to answers, range, we can only get, let's say, numbers up to 2, including 2. So you use 2, you get 2 as an answer, 1 as an answer, 0 as an answer, negative 1 as an answer, and continue those numbers there.